today is to introduce our novel water purification technology to you. So let's get right into it. Over a decade ago, our team of very clever engineers started by asking the following questions. 1. How do we extract pure water? 2. From any type of input stream. And 3. Without using large amounts of electricity. We reviewed what was available in the marketplace and saw two main methods. The first being reverse osmosis, which uses filters to screen solids. This requires second and third stage systems, which drives up the cost exponentially in order to process dirtier streams. With the other option of different types of mechanical presses, they use large amounts of energy to either wring out or spin out moisture from the input stream. With this in mind, the team took to the task and looked to nature for inspiration. What is nature's solution? This is something we're very familiar with, especially during the wet season, the rain cycle, the sun evaporating and distilling water molecules and separating it directly from the earth. To quote Elon Musk, can we tap this near limitless nuclear fusion device in our sky? To this dramatic effect. We took notes and went to the drawing board, attempting to mimic nature, and squeeze the evaporation and rain cycle into a device. There are quite a number of places in the world where solar irradiance is ideal for solar technologies. These places are generally the driest and have the most pressing water challenges. One country in particular is quite familiar to all of us, so let's zoom in. As you can see, Australia is a country perfect for solar. This is the initial prototype that we built. Trials were conducted with the Arizona State University. In this image, you can see that we've unhooked the system in order to see the steam being produced. Typically, the water is captured. We took the time to engineer ways to enhance the efficiencies of our design. First of all, we put the input stream under a vacuum. This drops the boiling point of water down to 83 degrees Celsius. During the conversion of water into steam, it pulls a large amount of heat in order to break its bonds. We hook the tubes back on itself, so when the steam condenses back into water, it preheats the water going in. This recycling of heat exchange retains the energy within the horizontal column, and we're able to get a gain-output ratio of 5.5 times with an estimated 11 times when we connect multiple units together. These are test results from produced water from fracking running through our device. We've dropped the TDS, which is the total dissolved solids, of 210,000 parts per million down to 12 parts per million. As a comparison, water from the tap is around 300 parts per million. Heartened by our results, we now have a full-scale design. What you see here is a 5-section device with a footprint of about 300 square meters. This produces an average of 40,000 liters of pure water per day. We can add multiple sections together to get a higher output in megaliters or gigaliter volumes. In essence, we're able to take pure water out from any still pumpable input and obtain a dry output. In fact, the more solids there are within the stream, the less water there is to heat, and it's actually more efficient the more solids there are. This is the exact opposite of current systems where high TDS inputs get quite challenging. So here are 3 simplified examples of our technology. 1, you're able to get a seawater or hypersaline brine as an input, you get pure water out and a dry salt out the end. You could put tailings in and get dry tailings at the end. You can also input sewage sludge and get biosolids. And with a few tweaks, we can even get biochar out of our device. Here's a quick look at Queensland and New South Wales biosolid stabilization requirements. By removing moisture to under 10% and a heat pasteurization process, we're able to produce grade A biosolids. We can go all the way down to 0 moisture. However, leaving some moisture is good to manage dust issues. In summary, we believe this is a game changer for industries. We can separate pure water out from many different types of input streams with insoluble solids like rock in it, and that's not a problem. We There's no costly filter replacements. We do not use filters or membranes. We can achieve zero liquids discharge at orders of magnitude cheaper than current systems. Most of it is because we're using solar as the energy input, which greatly reduces the electricity costs compared to other systems. This also saves a great amount on fuel, especially if you're running off a generator set without access to mains power. This is also scalable to megaliter and gigaliter volumes as the system is modular. We currently have 4 resource companies who are trialing our technology this year, and we're excited to share the results when we have them. If you see the potential in our technology to reverse our environmental impact on the planet, please note my contact details and get in touch. I really look forward to connect. We look forward to have your questions and thank you for your attention today.